So here I will show how to make the project and all. So this is the program for generation of the ramp here. So just I will copy this program. So I will open the Keil software. So previous I done the some of the work here. So just I will close the project. So just a new project here. So just have on the desktop. So on the desktop I will create the one folder. So which ramp here. Just I will write ramp folder name. So inside file name also just I will write this is the ramp. So what is the controller? Atmal 8089C 51 ED2 I need to select. So next I need to type the program for that editor. Just I will paste the program already I typed here. So this program I written for C program. So just I will save the file. So you can give the any name. Just I will give the ramp. C file means it should be the .c. If it is assembly you have to save .asm. So next target. So this should be the 11.0592 megahertz. So output I need to make the check mark. For the interfacing programs I need to make check mark. So even if you are writing the assembly programs also you can generate the HEX file. Here I am writing the C program. You can write the assembly programs also. At the time if you are interfacing programs you need to make check mark compulsory. So here next save the file. Again I need to attach this file. Source group, right click, add file, ramp. So it is appeared below the source group. So again I need to save, check the errors. Here there is no errors. So here this much only the work in Keil. So later I need to dump on the hardware. So for that I need to go for the second software. So that second software, which one is second software? This one is the second, Atmal Plif. So just open this software. So here first what to do here? First I need to select the device here. Select the device. So here which one is your device here? 8089C 51 ED2. Just select, click on OK. For interfacing programs I need to use interfacing this second software. So I need to make the connect. So here set communication. Click on this USB cable connection. Which one? We are using the RS232. So next you can keep just as it is whatever displaying. So just connect. Then all the options are it get enabled. So next task, first you have to select device, next connection, next I need to upload HEX file. So once you upload HEX file, it is going to show the names here. So first I will click on the file, load HEX file. So where is I created the file? On desktop. What is the name of the file? I entered ramp. So just open. Inside it will show the ramp, which type HEX. So this is a HEX file. So just I will make double click. Then whichever which one you uploaded the HEX file, you come to know the name of the file here, ramp HEX. This way you can realize which one I uploaded the HEX file here. So next thing you need to run it. It will show the progress in below here, erasing everything the devices and uploading the files. It will show the progress bar here. You have to wait for a few minutes. So I give few seconds. Once it will display memory verify pass. So that means once it become all the check mark, then everything is fine. So next you have to start application. Once you click on the start application, you see the results on the CROs. So only this much is the procedure. Once you click on the start application, then you can see the results on the hardware. So today's waveform generation, directly you can see the output on the CRO. Directly it will display. So here I done only for the ramp. Similarly, if you want to go for second waveforms, sine wave, similarly 3 waveforms I done. For 3 waveforms in the sense, you need to go for Keil. Again you have to create close this project. Close the project, again create the new project. So this way you should make the practice 4 different waveforms. Clear? So in the journal, just to write this one and just to draw the waveforms, that is enough. Clear? Thank you. One more very important, when you don't have the hardware kit, you can check the waveforms whether it is generating or not within the Keil software you can do with the help of the logic analyzer. So in the timers programs are done. So same thing we can check here. So here I am writing the P0 and P1 2 ports I am using because this is a dual DAC. You can generate the two waveforms with the help of the two DAC. Otherwise, you can write only the P0 and P1. That is left to you. So here, how to check within the Keil software? Go for the debug. So here I am using the P0 and P1 ports just to remember it. So here, click on the logic analyzer. So this is your logic analyzer, or you can go for view and click logic analyzer window. So here, view logic analyzer window. So first you have to set up the ports, which one you want to. P0 and P1 I am using. So here, click on the setup. So here, just I will demo. Here, click on this one, new insert. So just type whether it is small or capital, that is left. P0, just to press enter. It shows waveforms belongs to P0, it is color in the blue. If you want to change, you can change like this. So again, insert one more time. Which one is the P1? Again, press enter. Next, close. So again, which one is the run here? Once you click on the run, it will show the waveforms. So this one I written for program waveforms for ramp generation. So this way, for the different waveforms means you have to create the different project group. Sine wave, create the new project, then do the procedure. Again, square wave means again create the new project and do the procedure, same thing. So that means you can verify waveform generation within the Keil by using the logic analyzer window. Once you confirm this one, you can go for easily the hardware. Okay, I can get the output that will give the somewhat like confirmation whether should I get the results on hardware or not. Once it confirmed, definitely it will give output on the hardware. Clear? Thank you. So once you switch on the hardware, okay, after once you dump the HEX file on the controller board, at the time you can see the output on the CROs. So first I uploaded the HEX file for the square wave waveforms, generation of the square wave. So whatever you are seeing the output on the CRO, this is a generation of the square wave waveforms. So you can see this one. This is the logically 1. So this is your the logically 0. So that means it is not coming the clear picture. But if you want to join these lines, it will come exactly with the square waveforms. Clear? So this means this is the output of generation of the square wave. So only this much is output of this experiment. So similarly, we need to generate the triangular, we need to generate the ramp. Okay, so we'll see the one by one. So after the square wave waveforms, so this one is generation of the sine wave. So that means here we are not going to do anything on the CROs. So once you dump the HEX file on the controller, at the time automatically it will generate the waveforms on CROs. So here second waveforms you can observe. This one we can say this is the generation of the sine wave. Exactly. So that means when you are doing the experiment, you have to create the individual project for individual programs. Waveform generation, it should be the separate project file. So then once you created a HEX file, then once you upload it, it will generate the waveform for again square wave. If you want to perform the sine wave, it should be the individual project file. Exactly. So similarly, we can check the other waveforms also. So third waveform, that is generation of the ramp. So ramp is nothing but the structure should be like that only. So it is like this way here, incremental like that, linear. Again when it reaches here, again actually it will come this line drop out this way. So again it will go like this linear, again it will drop out. Exactly. So these lines are not actually visible here, but it should be comes like this. Exactly. So this is the third waveforms. So which one? This is the generation of the ramp. So one more last waveform, that is the triangular. So once you uploaded HEX file respect to the triangular, it will shows the generation of the triangular waveforms. So you can observe here. So whatever these two sides, it will be equal here. When you are going to draw the waveforms, this one, so total you have to find out the middle point here. So this side and this side should be the equal. So you can observe this is the triangular, continuous the triangular shape. Clear? So total 4 waveforms we studied. One is the sine wave, ramp, square wave. So last one is the triangular wave. So for this experiment, directly we are getting the output on the CROs only. Exactly. So these graphs you need to plot on the graphs. So these waveforms you need to plot on the graphs. Okay. So by taking the readings, just you have to plot it. Clear?